Carbylamine reaction or isocyanate test can be used for the detection of primary amines. Only primary amines will give this test, secondary and tertiary will not give. C6H5SO2Cl is called as benzene sulfonide chloride, or else it is also called as Hinsberg's reagent. In presence of bromine water, what is going to happen? 2, 4, 6. You can see here, this is first, second, third, fourth, fifth and sixth carbon. So 2, 4, 6, tribromoaniline is formed. Hello everyone, this is Ambli Unnikrishnan from the Department of Chemistry. So today I am back with session 4 of the chapter Amines. So in the last session we discussed about the physical properties of amines, wherein we discussed solubility, boiling points and basic character of amines. So then there was a comparison between the basicity of aryl amines, alkylamines and ammonia, right? So that order of basicity also we studied in the last session. So in today's session we are going to discuss the chemical properties of amines. So we are going to study acylation reaction, carbylamine reaction, reaction with nitrous acid, reaction with benzene sulfonide chloride, and then electrophilic aromatic substitution reactions we are going to see, wherein bromination, nitration and sulfonation we are going to discuss. By that we will come to an end to the discussion of the chemical properties of amines, and then later the last topic of the chapter, that is diazonium salts, we will start in the next session, right? So the first reaction is acylation or acetylation. So you already know what is acylation or acetylation. That means addition of an acyl group. What is acyl group? COCH3. So this is going to be substituted, right? So let's see. Primary and secondary amine, both aliphatic and aromatic, react with acid chlorides. Now what is acid chloride? RCOCl. This is called as acid chloride, right? So this COCl part, that is going to get substituted, right? Okay, so this is acid chloride. So this RCO part is going to be substituted, right? Anhydrides. So it can be acid chlorides or acid anhydrides and ester by nucleophilic substitution reaction. This reaction is known as acylation. So either you can use an acid chloride or acid anhydride or an ester. In all these groups, COCH3 is present, or else we can say RCO, any R group can be present. It can be alkyl group or aryl group, right? Now the products obtained by acylation reaction are known as N-substituted amides. So what we are going to get here? Amides we are going to get, and they are N-substituted. Okay, now it is a reversible reaction. So let's see the reaction here. RNH2 is taken, which is a primary amine. So primary and secondary amines will undergo this reaction. Now what is going to happen? CH3COCl, that is RCOCl, what it is? An acid chloride, right? So acid chloride, or you can also call it as acyl chloride. Now what is going to happen here is this COCH3 part is going to get attached to this nitrogen. So you will get an N-substituted amide, right? And this Cl and one H will be removed from here. One bond is coming here, right? So this H will be removed as HCl. You can see here HCl. Now what will happen? This COCH3 will form a bond with the nitrogen. So you will have RNHCOCH3, right? RNHCOCH3 is getting substituted in place of hydrogen. So that hydrogen being removed combines with the chlorine and forms HCl. I hope it is clear, right? Now acetyl chloride reacts with methylamine in the presence of pyridine base to form N-methyl acetamide. So you're getting an amide here. You can see it is CO. So you're getting an amide here, right? So the same way you're getting an amide here as well. So we have taken methylamine. Methylamine we have taken CH3NH2. CH3NH2 is called as methylamine or methanamine, right? It is going to react with CH3COCl, again an acetyl chloride. Now what is going to happen? Again, one of this hydrogen atom is going to be substituted by the COCH3 group. Now what happens? This H and Cl will combine and form HCl. What will be left behind? CH3NH you are having and COCH3. So that is what you can see here, CH3NH, COCH3. That is N-methyl ethanamide. Clear? So why it is called N? Because the nitrogen atom is having that functional group. Clear? Now, moving on to the next part, that is diethylamine reacts with acetyl chloride in the presence of pyridine base to form NN-diethylethanamide. So, here we have taken methanamine. Here we are going to take diethylamine. Okay. So, you can see two alkyl groups are there and NH is there. That is a secondary amine, right? All these were examples of primary amine. This is a secondary amine. Secondary amine also undergoes the same reaction. Now, again, it is going to react with acyl chloride. What is going to happen? this hydrogen is going to be substituted by the COCH3 group and HCl will be removed. So what will be there? C2H5N, C2H5, COCH3 will be formed. Clear? That is C2H5N, C2H5, COCH3, HCl will be removed. That is NN diethyl ethanamide will be formed. Why it is called NN diethyl? Because on the same nitrogen atom, you have one ethyl group, another ethyl group. So NN diethyl. Clear? Now, aniline reacts with acetyl chloride in the presence of pyridine base to form N-phenylethanamide. So now let's consider an aryl amine also. So we have taken C6H5NH2. Well, what is C6H5NH2? It is aniline, right? On benzene, you have NH2. This is called as aniline, right? So that is written in this format, C6H5NH2. Now what is going to happen? Again the same reaction. The COCH3 will share the electrons with nitrogen, and what is going to happen? One of this hydrogen atom will be replaced by the COCH3 and HCl will be removed. So what you are going to get? C6H5NH COCH3, right? C6H5NH COCH3 and HCl will be removed. That is N-phenylethanamide. I hope it is clear. Moving on to the next reaction, that is carbylamine reaction, which is a very important reaction. Okay, so when aliphatic and aromatic primary amines are heated with chloroform. So primary amines, it can be aliphatic or aromatic. They are heated with chloroform and ethanolic potassium hydroxide. Carbylamines or isocyanates. Carbylamines are also called as isocyanates are formed. This reaction is known as carbylamine reaction or isocyanate test. So the product you are going to get is called as carbylamine. Okay, that is why this reaction is called as carbylamine reaction. Okay, so now let's understand what is carbylamine. So this is used as a test for primary amines. So this is very important. Carbylamine reaction or isocyanate test can be used for the detection of primary amines. Only primary amines will give this test. Secondary and tertiary will not give. So if a particular amine is giving this test, means that it is a primary amine. Clear? Now these carbylamines have very unpleasant odor. So when carbylamine is formed, you can detect it by the smell itself. It's going to be a very disturbing smell. Secondary and tertiary amines do not respond to this test. This reaction is used as a test for primary amine. So you can remember that secondary and tertiary amines will not give a test for this. Only primary will follow this test. So that is why it is used as a detection for the identification of primary amines. Let's see, RNH2, it's a primary amine. It is going to react with chloroform and ethanolic potassium hydroxide, right? CHCl3, chloroform and potassium hydroxide. What is going to happen? RNC is formed. So this RNC is called as your carbylamine. Now there is a triple bond present here, R and triple bond C. Okay, so a carbylamine is formed and KCl is formed and water is being removed. Okay, so this is how this reaction will continue. So you have methylamine here, CH3NH2. It's going to react with chloroform and potassium hydroxide. What is going to happen? CH3 will remain there and this nitrogen and carbon will form a triple bond. Okay, CH3NC will be formed. It is also called as isocyanide. Right, isocyanide it is and KCl and water will be removed. Now you have C6H5NH2, aryl amine we are taking. Same way it is going to react with chloroform and potassium hydroxide. What you will get? C6H5N triple bond C, right? C6H5NC isocyanide will be formed. Which isocyanide? Phenyl isocyanide will be formed by the removal of KCl and water. So this is carbylamine reaction, which is used as a test for primary amines. Now, moving on to reaction with nitrous acid. Now, what is nitrous acid? Nitrous acid is HNO2. HNO2 is called as nitrous acid. Now, the reaction with aliphatic primary amines. So, what is aliphatic amine means? It does not have a ring structure. It will be a straight chain or a branched chain structure. So, aliphatic primary amines reacts with nitrous acid prepared in situ from NaNO2 and mineral acid like HCl. So, it is going to be prepared on the time of the reaction, that is by the reaction between NaNO2 and HCl. So, that is how you can prepare HNO2, that is nitrous acid, to form unstable aliphatic diazonium salt, which further produce alcohol and HCl, which the evolution of nitrogen gas by hydrolysis. Okay, so first what is going to happen? Primary amine is taken here, HNO2, nitrous acid, okay, which is prepared in situ by using NaNO2 and HCl. What is going to happen is first you are going to get a diazonium salt here. Diazo stands for two nitrogen atoms, that is N2. Okay, azo is for nitrogen, used for nitrogen. So diazonium means N2 will be there. So RNH2, what is going to form? A salt is being formed, RN2Cl minus, N2 plus Cl minus. So regarding diazonium salts, already you have an idea. We have studied diazonium salt reactions, right, in the previous chapter also. So N2 plus Cl minus will be formed, and then it is going to undergo hydrolysis. Hydrolysis added to the alkyl group. So you will get an alcohol, ROH alcohol. Then this N2 is going to be released as nitrogen gas. Left from the water you have an H as well, right? HOH is water. So this H and this Cl will combine and form HCl. Right, okay. Now let's take an example. Methylamine reacts with nitrous acid to form methyl alcohol with the evolution of nitrogen gas. CH3NH2, methylamine, reacts with nitrous acid HNO2 in presence of NaNO2 and HCl. What you are going to get? CH3NH2 and HNO2, nitrous acid. So what is going to happen? This NH2 is going to be N2 plus and Cl minus. Right, so you will get the diazonium salt, and then hydrolysis is going to take place. What is going to happen? This will be removed as nitrogen gas. This Cl and the H from it will form the HCl, and you have an OH which is going to form a bond with the carbon. So you will get methanol, nitrogen gas and HCl. So this is the reaction with nitrous acids. Now this was the reaction with nitrous acid if you are taking a primary amine. Now let us take an aromatic primary amine. This was a aliphatic primary amine, right? Now we are taking a aromatic primary amine. So this reaction is called as diazotization reaction. So we have already studied this. Aromatic primary amines reacts with again nitrous acid. It can be NaNO2 and HCl at low temperatures to form diazonium salt. This reaction is called as diazotization. For example, on treatment with NaNO2 and HCl at 273 to 278 Kelvin, aniline produces benzene diazonium chloride with NaCl and H2O as byproducts. So you can see here C6H5NH2, that is aniline, okay, in presence of nitrous acid, which is prepared in situ from NaNO2 and HCl, right? And it happens at 273 to 278 Kelvin. What is going to happen? Benzene diazonium salt will be formed. That is, this NH2 becomes N2 plus Cl minus. So between these two nitrogen atoms, there will be a triple bond which is present. Okay. And apart from that, sodium chloride and water will be present, right? Sodium chloride and water will be present. So this is how the reaction will proceed. Benzene diazonium salt you are going to get. Now the next reaction is reaction with benzene sulfonyl chloride. Benzene sulfonyl chloride, it is C6H5SO2Cl. C6H5SO2Cl is called as benzene sulfonyl chloride, or else it is also called as Hinsberg's reagent. Hinsberg's reagent. Okay. So benzene sulfonyl chloride, Hinsberg's reagent, reacts with primary and secondary amines to form sulfonamides. Okay, so it is important to remember what is Hinsberg's reagent. So that can be also a question. What is Hinsberg reagent? Benzene sulfonyl chloride. So you should be knowing that. In this reaction, the amines are allowed to react with Hinsberg's reagent, that is benzene sulfonyl chloride. The three types of amines reacts differently with Hinsberg's reagent. Therefore, they can be easily identified using Hinsberg's reagent. So this is an important reaction because Hinsberg reagent, that is benzene sulfonyl chloride, helps us to identify whether the given amine is a primary amine, secondary amine or tertiary amine, because all of these amines will react differently in presence of Hinsberg reagent. So primary amine react with benzene sulfonyl chloride to form N-alkyl benzene sulfonyl amide, which is soluble in alkali. Okay, so if primary amines are present, then it reacts with Hinsberg's reagent and it forms N-alkyl benzene sulfonyl amide, which is soluble in an alkali. Alkali means any base. So it will be soluble in alkali. So let's see the reaction. So this part, you can see benzene is here, SO2 is here, Cl is there. So this is your C6H5SO2Cl, Hinsberg's reagent, plus what we have taken here is a primary amine, C2H5NH2, right? It's a primary amine. So what is going to happen here is, from the amine hydrogen and from the benzene sulfonide chloride, the HCl will be removed. So what is going to happen? This HCl will be removed and this much part will attach with the sulfur. So what you will get? The C6H5SO2 will be there and you will have NHC2H5. See, NHC2H5 by the removal of this HCl. Clear? So it's a simple reaction. So what is going to happen? N-ethyl benzene sulfonamide will be formed, which is soluble in alkali. Due to the presence of a strong electron withdrawing sulfonyl group in the sulfonamide, the hydrogen atom attached to the nitrogen can easily be released as a proton. So it is acidic and dissolves in alkali. So this hydrogen can be easily removed. Okay, so that is why easily this reaction will take place and it will be soluble in an alkali. Okay, so this is how primary amines will react with Hinsberg reagent. It will be soluble in alkali. Now moving on to secondary amines, it reacts with Hinsberg reagent to give sulfonamide itself, which is insoluble in alkali. So that is a difference between primary and secondary amine. Secondary amine will be insoluble in alkali, but the reaction will be same. You can see here. So you have your benzene sulfonyl chloride and C2H5NH. So that means you are having a diethyl amine, which is a secondary amine. Now what is going to happen? Again the same way HCl is going to be removed. So you will have C6H5SO2 and NC2H5C2H5. So this is what you are going to get by the removal of HCl. That is NN diethyl benzene sulfonamide is formed, right? So what is going to happen? There is no hydrogen atom attached to the nitrogen atom in the sulfonamide. Therefore it is not acidic and insoluble in alkali. Okay. So if a substance is supposed to be acidic, means it has to have the tendency to donate its H plus ions. But in this case, the sulfonamide, there is no hydrogen atoms present. But here you have one hydrogen atom which is present, right? Therefore, it is acidic. So it will be soluble in alkali. But the sulfonamide formed here does not have any hydrogen atom to release. Okay, so that is why it is not acting as an acid. It is not acidic. Hence, it is of course not going to be soluble in an alkali. So that is how the difference would be. The primary and secondary amine. Now, on the other hand, tertiary amines do not react with Hinsberg reagent at all. Okay, so these are the three differences between primary, secondary and tertiary. In both the cases of primary and secondary, what will be formed? Sulfonamide will be formed. But primary will be soluble in alkali because it is acidic in nature. Secondary will not be soluble in alkali and tertiary will not give a reaction with Hinsberg reaction, Hinsberg reagent itself. So that's how you can differentiate primary, secondary and tertiary. So if in the question paper you see the question, which is the test used to differentiate between primary, secondary and tertiary amine, you can write this particular reaction. Now moving on to electrophilic aromatic substitution reaction. So we are going to study about electrophilic substitution. That means in an aromatic system, an electrophile is going to be substituted. So what are electrophile? Electrophile means which is having attraction towards negatively charged substances. So it itself will be positively charged, right? So aryl amines are very reactive towards electrophilic to aromatic substitution reactions. This is because NH2, NHR2 and NR2 are very strong active groups and are ortho-para directing, gives ortho and para substituted products. So your amino group NH2 is ortho-para directing. So that you have to remember. So if an electrophile is added, okay, what is going to happen? It is going to be substituted in the para and ortho position. Okay, it's an ortho-para directing group. It's a powerful activating group and ortho-para directing. So let's take the first reaction, that is bromination. Bromination means what? Bromine group is going to be substituted. So aniline reacts with bromine water at room temperature to give a white precipitate of 2,4,6 tribromoaniline. So it's not different products you are getting. The ortho and para will be substituted in the same product itself. So you can see aniline and 3 moles of bromine we are going to take. In presence of bromine water, what is going to happen? 2, 4, 6. You can see here, this is first, second, third, fourth, fifth and sixth carbon. So 2, 4, 6 tribromoaniline is formed. Clear? Now that is about bromination. So it is going to be a white precipitate which is formed. Now in bromination itself, if you require a single substituted product, that means either in the ortho or para position only, this is a tri-substituted product that you are going to get. If you require a mono-substituted product, let's see how we can do that. Mono-substituted aniline derivative can be obtained by protecting amine group by substitution. Hydrolysis of substituted amide gives substituted amine. So let's see. Aniline we have taken. So CH3COCl, acid chloride is taken in presence of pyridine. What is going to happen? This acyl group is going to be added here by the removal of HCl. HCl will be removed. So we have already studied this reaction in acylation, right? So what you are going to get? NHCOCH3. So from this one hydrogen and HCl and Cl will be removed as HCl. So COCH3 is going to get attached with the nitrogen. So now what is happening? Now then we are going to react it with bromine. Okay, then what happens? The bromine is going to be substituted in the para position. It's going to get substituted in the para position. Now again, if we are adding H plus or OH minus, hydrolysis is going to take place. What is going to happen? Here NH2 will come and this COCH3 and OH from the water will be added and form what? CH3COOH, and from water one H will be also there. No, that H will be attached here and you will get NH2 and the bromine here. Okay, so the COCH3. So the COCH3 and OH will form the acid here and you will get 4-bromoaniline. That is a single substituted or mono substituted product you are going to get. So this is how you have to proceed. So directly when the aromatic amine reacts with bromine water, what is going to happen? You will get a tri-substituted product. But if you require a mono substituted product, first you have to react it with acetyl chloride and it forms the substituted product, that is N-phenylethanamide, and further it undergoes hydrolysis and forms the para substituted product. Now the next one is nitration. So we are going to add a nitro group, substituting a nitro group. Direct nitration of aniline with nitric acid gives a complex mixture of mono, di and trinitro compounds and oxidation products. If direct nitration of amine is carried out in the presence of a mixture of concentrated HNO3 and concentrated H2SO4, that is called as a nitrating mixture, right? Aniline gets protonated to form anilinium ion, which is meta-directing. Hence, nitration of aniline gives meta-derivative along with ortho and para. Okay, so in nitration, what you have to remember is 3 products will be formed, that is ortho, para and meta products will be formed. So you can see here aniline reacts with nitric acid and sulfuric acid, nitrating mixture. What is going to happen? Nitro group substituted in the para position, in the meta position, in the ortho position. So in all the positions you are going to get. Okay, so you can see here itself the para product will be the most, then you will have meta and the least will be ortho. Okay, so that is how the reaction proceeds in nitration. Now mono-substituted aniline derivative can be obtained by protecting amine group by acetylation with acetyl chloride. The same way which we have done for bromination, same way first we have to protect the amino group and then the further reaction can take place. Then carry out the desired substitution followed by hydrolysis of the substituted amine to the substituted amine will be formed. Thus, nitration of aniline is carried out by first protecting amino group by acetylation with acetic anhydride. The nitration reaction can be controlled and the para-nitro derivative can be obtained as a major product. So, in here, if you are directly using the nitrating mixture, ortho, para and meta will be also there, will be formed. But if you require a mono substituted product, what you are going to do? First, it is going to react with acetyl chloride. So, what is going to happen? One hydrogen will be removed as HCl and you will get NHCOCH3. Okay, now we are going to react it with nitric acid. So, first acetyl chloride, you will get a N-phenylethanamide will be formed. Now it is going to react with nitric acid. What you are going to get? The nitro group will be substituted in the para position. Now you require only NH2 here, right? Aniline should be there. So what is that you are going to add? H2O you are going to add. So this will be removed as CH3COOH, right? OH will be added here. So you will get what? Acid will be formed and the hydrogen will be added here. You will get aniline and it is a para-nitroaniline. Only para form will be formed. So this is how nitration can proceed. If you require all the para, ortho and meta, this is the reaction, that is directly nitrating mixture you can add, or else first you have to protect the amino group by adding acetyl chloride and then it can react with the nitrating mixture. Now the last one is sulfonation. Aniline reacts with concentrated sulfuric acid to form anilinium hydrogen sulfate, which on heating with sulfuric acid produces para-aminobenzene sulfonic acid, commonly known as sulfanilic acid, as the major product. Okay, so let's see here, aniline reacts with sulfuric acid. What is that you are going to get? NH3HSO4 minus. H2SO4 I am adding. Right, so HSO4 minus will be there and one more H is there, no, that is going to be added to the NH2. You will get NH3 plus HSO4 minus. That is anilinium hydrogen sulfate. Okay, so you have NH2 here, to which I am adding H 2SO4, right? So this hydrogen combines with this and forms NH3 plus, and what you have HSO4 minus. So this is anilinium hydrogen sulfate. Now, if you are heating under 453 to 473 Kelvin, what is going to happen? Again, in presence of sulfuric acid, sulfanilic acid will be formed. So, you will get the SO2H here. So, the amino group will be retained here. Okay, and the zwitterion ion formed is NH3 plus and SO3 minus. That is, this H can go here and form NH3 plus. Right. So, in that way, sulfanilic acid will be formed. Clear? So, the next session, we are going to start off with the next topic, that is diazonium salt. The same way we have discussed about amines, we are going to discuss the physical properties, chemical properties, preparation, all of that regarding diazonium salt. So, I hope the concepts I have covered in this session is clear for you. So, that's all for today. Thank you.